Imagine a bullet made of pure light, not a laser, not a flashlight. A concentration of photons so dense, so impossibly bright, that the light itself breaks reality. It doesn't just illuminate, it doesn't just burn, it bends spacetime, it creates gravity, it punches a hole through the fabric of the universe and becomes the one thing nature never intended light to become: a prison, a trap. A cosmic event horizon formed not from dead stars, not from collapsed matter, but from energy itself. This is the Kugelblitz, German for ball lightning, but don't let that quaint translation fool you. This isn't weather. This isn't some atmospheric anomaly you can photograph from your porch. This is a black hole made of light, and it might be the most terrifying object in theoretical physics. Because here's the nightmare fuel. Everything you know about black holes tells you they form when massive stars die, when matter collapses under its own weight, when gravity wins the war against every other force in nature. But the Kugelblitz, it proves gravity doesn't care about matter at all. Gravity cares about one thing and one thing only: energy. And light is nothing but energy. Pure, massless, unstoppable energy. Which means, in theory, you could create a black hole without a single atom. You could create a black hole in a lab. You could create a black hole by accident. You could create a black hole that swallows the Earth before anyone realizes what went wrong. And if that sounds like science fiction, buckle up, because the math says it's not only possible, it's inevitable under the right conditions. Conditions that might already exist somewhere in the universe right now. Let's start with something you think you understand. E equals mc squared. Energy equals mass times the speed of light squared. Einstein's most famous equation, the blueprint for nuclear weapons, nuclear power, and the entire atomic age. But here's what popular science forgot to tell you. Einstein wasn't saying energy and mass are similar. He was saying they're the same thing. Identical, interchangeable. Mass is just energy that got lazy and sat down. Energy is mass that got up and started moving at the speed of light. This isn't philosophy. This is the operating system of the universe. Your body, it's energy bound into matter. The chair you're sitting on, compressed energy. The device you're watching this on, organized energy pretending to be solid. And light? Photons? They don't have mass. That's why they travel at light speed. That's why nothing can catch them. But they have something else. They have energy, and according to Einstein, energy and mass are the same currency. Which brings us to gravity. Newton taught us that gravity is the attraction between masses. Apple falls from tree. Earth orbits sun. Simple, elegant. Wrong enough to be dangerous. Einstein came along and said no, gravity isn't a force between objects. Gravity is geometry. It's the bending of space-time itself. Mass doesn't pull other mass toward it. Mass bends the fabric of reality, and everything else just follows the curve. But here's the critical part that changes everything. Einstein's field equations don't mention mass. They mention energy, stress, momentum, pressure. Mass appears because mass contains energy, but the equations themselves are blind to whether the energy comes from a mountain or a laser beam. To gravity, a kilogram of iron and a kilogram of light are identical twins. Let that sink in. The thing that makes black holes, the impossible curvature of spacetime that traps even light itself, doesn't require matter. It requires energy density. Concentration. The universe doesn't care what form the energy takes. It only cares how much you can pack into how small a space. So how do you actually build one of these things? How do you turn light into a black hole? Picture this. You have a perfectly spherical mirror. A Dyson sphere if you want to get science fictional about it. Inside this sphere, you place a light source, not a bulb, something more aggressive, a gamma-ray generator. The most energetic light in the electromagnetic spectrum. You turn it on, the light bounces around inside the sphere, trapped, more and more photons filling the space. Normally, Light passes through light without interacting. Shine two flashlight beams across each other and they don't collide. They don't push. They ignore each other completely. But at extreme energy densities, something changes. Photons don't have mass, but they carry momentum. They exert pressure. This is called radiation pressure, and it's the reason comet tails point away from the sun. It's why solar sails work. Light pushes. If you pack enough photons into a small enough volume, the radiation pressure doesn't just push outward against the mirror, it pushes inward. The photons start pushing against each other. The energy density climbs, and because energy is equivalent to mass, the spacetime inside that sphere starts to curve. At first, just a little. A gentle dimple in the fabric of reality. But you keep adding light. The generator screams, the sphere fills with pure energy, and the dimple deepens. The curvature increases. The photons are now traveling through bent space that they themselves created, which bends the space even more. It's a feedback loop from hell. Energy creates gravity. Gravity compresses space. Compressed space traps more energy. More energy creates more gravity. Until one moment, one exact, catastrophic instant, the curvature becomes infinite. The escape velocity at the surface exceeds the speed of light. And just like that, without a single atom of matter involved, an event horizon forms. A black hole made entirely of light. A Kugelblitz. And here's the truly horrifying part. Once that horizon forms, nothing inside can get out. Not the photons that created it. Not the energy sustaining it. The light has trapped itself. It has eaten itself and become a hunger that can never be satisfied. You might be thinking, okay, theoretically terrifying, but practically impossible, right? Surely you need an absurd amount of light to pull this off. Oh, you have no idea. Let's talk numbers, but not the boring kind. The kind that make your brain refuse to process them. To create a Kugelblitz the size of a grapefruit, a sphere about 10 centimeters in radius, you need to focus roughly 1023 joules of electromagnetic energy into that space. That's a 1 followed by 23 zeros. For context, the entire human civilization currently consumes about 6x 1020 joules per year. So that grapefruit-sized Kugelblitz requires the total energy output of every power plant, every solar panel, every burning lump of coal on Earth for about 2 centuries. But wait, it gets worse. Because you can't just generate that energy slowly. You have to focus it all simultaneously. Within a sphere small enough that the energy density warps spacetime before the light escapes, we're talking about compressing 200 years of planetary power output into a space smaller than your fist, in a time frame measured in nanoseconds. The power requirements, beyond staggering. We're not in the realm of we need better technology, we're in the realm of we need to rebuild the laws of thermodynamics. A Kugelblitz the mass of Mount Everest, which would have a Schwarzschild radius smaller than a proton, would require the entire energy output of the sun for a week, concentrated into a space you couldn't see with the naked eye. This isn't an engineering problem. This is a you would need to become a Kardashev Type 2 civilization and command the resources of an entire star system problem. So we're safe, right? No accident is going to create one of these. No laboratory experiment is going to stumble into it. The Large Hadron Collider isn't going to accidentally focus a beam hard enough to birth a light-eating monster. Except nature doesn't care about our engineering limitations. Nature has bigger budgets than we do. Nature has gamma-ray bursts. Gamma-ray bursts are the brightest electromagnetic events known to occur in the universe. They outshine the rest of their galaxy combined. They release more energy in a few seconds than the sun will produce in its entire 10 billion year lifetime. They happen when massive stars collapse or when neutron stars collide. The energy release is so incomprehensibly vast that for decades, astronomers couldn't even theorize a mechanism powerful enough to create them. And here's the question that keeps theoretical physicists staring at ceilings at 3 a.m. What if some gamma-ray bursts aren't just explosions? What if there's something else? What if, in the heart of that cataclysm, for a fraction of a second, the energy density becomes so extreme that space-time itself folds? Not into a matter-based black hole, we see those all the time, but into something far more exotic. A Kugelblitz born in the fires of a dying star. A black hole made not from the star's corpse, but from its death scream. From pure radiation. The math doesn't rule it out. In fact, the math suggests that in the earliest microseconds of a gamma-ray burst, conditions might be exactly right. The radiation pressure, the energy density, the geometry of the collapsing system, it might all align. We wouldn't detect it differently. A Kugelblitz, once formed, has no hair. That's not a joke, it's a theorem. The no-hair theorem states that a black hole can only be characterized by three externally observable properties: mass, electric charge, and angular momentum. It doesn't matter what fell in, matter, antimatter, light, dark energy. Once it crosses the event horizon, the universe forgets what it was, which means a Kugelblitz looks identical to a regular black hole. It bends light the same way. It evaporates via Hawking radiation the same way. It gravitationally lensing the same way. There could be millions of them out there, drifting between galaxies, and we would have no way of knowing they were made of light. They could be in our galaxy right now. Invisible, silent, perfect traps for anything unfortunate enough to cross their path. And if one wandered into our solar system, if one passed through the Oort cloud, disturbing comets, cutting through the inner planets, we wouldn't see it coming, we'd only see the effects. Orbits shifting, light bending around something that emits no light itself, a darkness made of pure light. Okay, time for the central claim. Why is a Kugelblitz deadlier than a regular black hole? A normal black hole forms from matter, and matter, as destructive as it is, has rules. It has limits, it clumps, it accretes, it falls in gradually, creating friction, heating up, emitting radiation. We can see accretion disks, we can see the jets, we can detect the X-rays screaming from the edge of doom. A matter black hole grows by eating matter. It pulls in gas, dust, stars, but matter resists. It has angular momentum, it forms disks, it fights back in its own way. A Kugelblitz. It doesn't have those limitations because it's made of energy, because energy and matter interact with the universe differently. Consider this. If you create a Kugelblitz artificially, if some future civilization figures out how to do it, you don't need to mine a star. You don't need to collapse matter. You just need energy. And energy is everywhere. More terrifyingly, a Kugelblitz could theoretically be stable at any size. Regular black holes have a minimum mass, the Planck mass, below which quantum effects dominate and the concept of classical black holes breaks down. But a Kugelblitz, because it's made of bosons rather than fermions, behaves differently at quantum scales. Photons are bosons. They can occupy the same quantum state. They can overlap infinitely. They don't have the Pauli exclusion principle telling them, no, you can't be here, this space is full. This means a Kugelblitz could, in theory, be created at microscopic scales. A quantum Kugelblitz. A black hole smaller than an atom, made of light, evaporating almost instantly via Hawking radiation. But here's the catch. Hawking radiation from a microscopic black hole is explosive, not gentle dissipation, a violent, instantaneous conversion of mass energy into a spray of high-energy particles. Gamma rays, X-rays, a microscopic bomb with the force of a nuclear weapon. So now you have a scenario where a sufficiently advanced civilization or a sufficiently unlucky accident could create not just a black hole, but a black hole bomb, a weapon of literally astronomical power that leaves no fallout, no radiation signature, no evidence except the crater where a city used to be. A regular black hole is a cosmic garbage disposal. A Kugelblitz is a cosmic gun, and unlike matter black holes, which announce their presence with gravitational waves and electromagnetic chaos, a Kugelblitz born in the void between stars would be silent until it was too late. Let's play a dangerous game. Let's say humanity survives the next 1,000 years. We become a Type 1 civilization. We harness planetary energy. We build megastructures in orbit. We command the physics of our solar system. Could we build a Kugelblitz? The theoretical pathway exists. It's called a gamma-ray laser, or grazer, a device that focuses gamma radiation into a coherent beam. Unlike regular lasers, which bounce photons between mirrors, a grazer would use stimulated emission from nuclear isomers, atoms in excited nuclear states, to produce gamma photons. If you took that grazer, and instead of pointing it at a target, you aimed it into a perfect spherical reflector. If you fired it for long enough, with enough power, if the energy density inside that sphere crossed the threshold, you would not get an explosion, you would not get a fireball, you would get a gravitational collapse. The light would curve inward, the event horizon would form, and the Kugelblitz would begin. Of course, the energy requirements are still beyond us, by many orders of magnitude, but beyond us is not the same as impossible. There are speculative designs, Robert Forward's light traps, Craig Wheeler's photon rockets, that suggest methods of concentrating light beyond anything we can currently achieve. And here's where it gets ethically terrifying. Unlike a matter black hole, which requires astronomical mass and naturally forms in space, a Kugelblitz is theoretically achievable with focused energy, which means it's theoretically achievable in a laboratory setting. Given sufficient advancement, the Large Hadron Collider can't do it. Not even close. But a future particle collider, a gamma-ray facility 1,000 times more powerful, a weapon system designed to concentrate energy for propulsion or defense. We don't know where the boundary is. We don't know if there's a hard physical law preventing microscopic Kugelblitz formation. We only know that Einstein says energy creates gravity, and we know that we're getting very, very good at creating extreme energy densities. Every time we build a bigger laser, every time we achieve higher temperatures in fusion experiments, every time we concentrate photons into tighter beams, we're taking another step toward the Kugelblitz threshold. Not close. Not yet, but moving in that direction. But let's go deeper. Let's get into the quantum horror. You know about the black hole information paradox, right? If you throw a book into a black hole, the information in that book seems to disappear forever. Quantum mechanics says information is conserved. Black holes say information is gone. This contradiction has broken physicists' brains for 50 years. Now imagine throwing light into a Kugelblitz. But not just light, information encoded in light. Because here's the thing about photons. They carry information. Every photon that reaches your eye from a distant star tells a story. Its wavelength encodes temperature, its polarization encodes magnetic fields. Its journey encodes the geometry of the universe between you and the source. If a Kugelblitz swallows light, it's swallowing pure information, not matter that can be crushed into a singularity, not particles that can be stripped of identity. Photons are fundamental. They are as close to pure information as physics gets. So what happens when a Kugelblitz evaporates? Stephen Hawking proved that black holes emit radiation. They slowly lose mass, fizzling away over trillions of years until they vanish in a final flash. For matter black holes, this is weird enough. The information paradox asks, where did the book go? Where did the atoms go? For a Kugelblitz, the question is more disturbing. Where did the light go? If the black hole was made of photons and it evaporates into photons, is the information preserved? Can you reconstruct the original light from the Hawking radiation, or does the Kugelblitz destroy information in a way that matter black holes don't? Some theorists suggest that a Kugelblitz might evaporate differently than a Schwarzschild black hole. Because it formed from bosons, Because it has different quantum statistics, its Hawking radiation spectrum might be unique. It might release its energy in bursts rather than a steady glow. It might violate thermodynamic assumptions that matter black holes obey. In other words, we understand matter black holes well enough to be terrified of them. We don't understand Kugelblitzes well enough to know what happens when they die, and if one ever formed, naturally or artificially, its death might be more dangerous than its life. A dying Kugelblitz might not gently radiate away. It might detonate. It might release all its stored energy in a single catastrophic burst of gamma radiation. A black hole bomb made of light, dying in a flash of light. The universe has a dark sense of humor. Let's bring this home. Literally, a Kugelblitz doesn't have to be big to destroy Earth. It doesn't have to be stellar mass. It just has to be stable long enough to start eating. If a Kugelblitz the size of a marble appeared in low Earth orbit, it wouldn't crash into the planet. It wouldn't need to. It would fall, and as it fell, it would pass through the atmosphere, consuming air molecules, converting their mass into energy, growing larger. The entry would look like a second sun, a streak of impossible brightness as matter annihilates against the event horizon. The sky would light up, the temperature would spike locally, and then silence. Because once it hit the surface, once it burrowed into the crust, it would start eating the planet from the inside out, not in seconds. Black holes, even dangerous ones, don't consume that fast. A marble-sized Kugelblitz might take years to devour Earth, but the process would be unstoppable. Earthquakes as mass shifts toward the singularity, volcanic eruptions as the mantle is punctured. The planet would literally ring like a bell as the Kugelblitz oscillated through the core, consuming iron, nickel, silicate rock, converting it all into pure gravitational energy and Hawking radiation. The surface would become uninhabitable long before the planet was fully consumed. Tidal forces would distort the crust. The atmosphere would be stripped and swallowed. The oceans would boil, then fall, and through it all, the Kugelblitz would remain invisible. A perfect sphere of blackness, barely larger than a marble, sitting at the center of a dying world. Unlike an asteroid impact, which is sudden, or a supernova, which is distant, a Kugelblitz consumption would be slow, agonizing, the universe's most terrible way to die, being digested one atom at a time by a monster made of light. But here's the thought that should truly keep you awake. We know black holes exist. We've photographed them. We've detected their gravitational waves. They are commonplace in the universe. But Kugelblitzes? We've never seen one. We've never detected one. They remain purely theoretical. Or do we just not know how to look? Remember, the no-hair theorem says they're identical to matter black holes. Same mass, same charge, same spin, no external difference. So when LIGO detects a black hole merger, two singularities colliding, warping spacetime, ringing the universe like a drum, we assume those black holes formed from collapsed stars. But we can't know. We can't see inside the event horizon. We can't measure what fell in. Some percentage of the black holes in our universe, perhaps all of them, could be Kugelblitzes. Natural ones, formed in the energetic chaos of the early universe, or in the hearts of gamma-ray bursts, or in conditions we haven't imagined. They could be the dark matter we've been searching for. Invisible not because they don't interact with light, but because they are light, trapped, folded, hidden behind their own event horizons. The universe might be filled with ancient Kugelblitzes, drifting through galactic halos, anchoring galaxies with their gravity, shaping the large-scale structure of the cosmos. Not matter at all, pure energy locked in gravitational prisons, holding the universe together. We spent decades looking for WIMPs and axions. Maybe dark matter is just light that got too heavy for its own good. Let's step back from the physics for a moment and talk about what the Kugelblitz means. Light is supposed to be the fastest thing in the universe, the cosmic speed limit, the messenger that carries information across the void. It is the foundation of electromagnetism, of chemistry, of sight itself. Light is supposed to be free. The Kugelblitz says no. It says that even light can be imprisoned. Even the fastest thing in existence can be trapped by its own energy. Even pure motion can be brought to a standstill so absolute that time itself stops at the boundary. There's something deeply unsettling about that. A matter black hole is just gravity doing what gravity does. Massive things collapse. We expect that. We can rationalize it. But a Kugelblitz is different. It's a prison made of the prisoner. It's a trap built from freedom itself. Light, the ultimate escape artist, caught in a jail it constructed. It tells us that nothing is safe, not speed, not energy, not light. The universe has a way of turning everything against itself. Creation contains the seeds of destruction. Freedom contains the blueprint for prison. If light can become a black hole, what else can? Can gravitational waves become trapped in their own curvature? Can dark energy collapse? Can space-time itself fold so tightly that it pinches off from the rest of the universe, forming a baby cosmos that eats its parent? The Kugelblitz isn't just a monster, it's a warning. It says that the categories we use to understand the universe, matter versus energy, particle versus wave, freedom versus imprisonment, are illusions. At sufficient extremes, everything becomes everything else. Mass becomes energy. Energy becomes gravity. Gravity becomes a prison. And the prison becomes eternal. So where does this leave us? The Kugelblitz is theoretical. It has never been observed. It may never be created. It exists primarily in the notebooks of physicists who specialize in the kind of mathematics that requires multiple dimensions and exotic geometries. But theoretical does not mean imaginary. Black holes were theoretical once. So were neutron stars. So were gravitational waves. So was the Big Bang. Every monster in the cosmic zoo started as a nightmare in an equation. The difference with the Kugelblitz is that we might be able to make one. Not today. Not this century, but eventually. And once you can make something, someone will. Whether out of curiosity, out of ambition, or out of the same species-level compulsion that drove us to build nuclear weapons, we will build it. Because that's what we do. We look at the universe, we see its dangers, and instead of running, we ask, how? How do we create a black hole? How do we harness its energy? How do we weaponize it? Commercialize it, turn it into a propulsion system, or a power plant, or a method of disposing of nuclear waste. The Kugelblitz offers advantages that matter black holes don't. It's cleaner, it doesn't require stellar mass, it can theoretically be any size, it can be created with energy, and energy is easier to manipulate than matter. It's the ultimate endgame of technological progress, the point where our tools become too powerful to control, where our understanding of physics outpaces our wisdom. And if we ever do create one, if some future civilization, arrogant with its mastery of energy, focuses a gamma-ray laser into a perfect sphere and crosses the threshold, they won't get a second chance. Because unlike other experiments, you can't shut off a Kugelblitz. You can't contain it. You can't modify the parameters. Once the event horizon forms, it's no longer an experiment. It's a predator. Omniscience in sia. Right now, as you watch this, the universe is expanding. Stars are dying. Galaxies are colliding. In the void between them, light travels for billions of years, carrying information across impossible distances. And somewhere in that darkness, perhaps, there are Kugelblitzes, drifting, silent, perfect spheres of trapped light, invisible against the black background of space. They don't hunger, they don't think, they don't chase, they simply bend space-time, and anything that comes too close falls in. No malice, no intent, just geometry, just physics, just the inevitable consequence of concentrating too much energy in too small a space. They are the universe's way of reminding us that even light has weight, even speed has limits, even energy can become a cage. And if one ever comes for us, if we ever detect an object that bends starlight but emits no radiation of its own, That has the mass of a mountain, but the size of a pinhead, that devours matter with silent efficiency, we won't be able to fight it. We can't blow up a black hole. We can't outrun it. We can't appeal to its better nature. The only defense against a Kugelblitz is distance. The only safety is not being near it when it forms. But we won't see it coming, because it's made of light. And in a universe full of light, how do you spot the light that has become a trap? There's a final cruelty to the Kugelblitz that bears mentioning. We use light to see. We use light to communicate. We use light to understand the universe. Every image from the Hubble Space Telescope, every signal from a Mars rover, every sunset you've ever watched, it's all light, and the Kugelblitz says that the very thing we use to discover the universe can become the thing that destroys us. Not metaphorically, literally. The photons that reveal the stars can, under extreme conditions, become a star-eater. It's the cosmic equivalent of discovering that oxygen can suffocate you, or that water can dehydrate you. The tool becomes the weapon. The messenger becomes the executioner. We look to the light for hope, for truth, for beauty. We tell ourselves that no matter how dark the universe gets, there's always light somewhere. But the Kugelblitz stands as proof that even hope can be weaponized. Even truth can be trapped. Even beauty can collapse under its own weight. The universe doesn't care about our metaphors. It doesn't care that we call light good and darkness evil. It only cares about energy density and curvature and the cold equations of general relativity. In a universe where light itself can become a prison, nothing is sacred. Nothing is safe, and the only protection we have is the fact that, for now, the Kugelblitz remains theoretical. For now. So here is the Kugelblitz, the black hole made of light, the prison built by its own prisoner, the deadliest object in theoretical physics, deadlier than a matter black hole because it can form from pure energy, deadlier because we might be able to create one, deadlier because it leaves no trace, no warning, no evidence of its true nature until it's too late. It represents the ultimate boundary of physics, the place where Einstein's relativity meets quantum mechanics in the most violent way possible. The proof that even massless particles, moving at the speed of light, cannot escape the geometry they create. If you take one thing from this, let it be this: the universe is not our friend. It is not hostile either. It is indifferent. And that indifference takes forms that outstrip our darkest nightmares. A Kugelblitz is not evil. It doesn't hate us. It simply exists in the equations, in the potential futures of an advanced civilization, in the hearts of distant gamma-ray bursts. But if one ever forms, if the light ever turns against itself, we will learn the ultimate lesson of the cosmos, that everything can be a weapon, that everything can become a trap, that even the fastest thing in the universe can be brought to a permanent, eternal, absolute stop. The light that eats. The Kugelblitz. Sleeping in the math, waiting for the day when someone, somewhere, focuses enough energy into a small enough space to wake it up. Let's hope that day never comes, because when it does, there will be no warning, no defense, no escape, just light, trapped light. Hungry light, and the silence that follows.